Section 8.7 is translating sine and cosine functions. Our goal is to graph translations of trigonometric functions and write equations of translations. On page 628, we have recalled that for any function f, you can graph f of x minus h by translating the graph of f h units horizontally. You can graph f of x plus k by translating the graph of f by k units vertically. You can translate periodic functions in the same way that you translate other functions. Each horizontal translation of certain periodic functions is a phase shift. Horizontal translations move side to side, and vertical translations will shift up and down. When g of x equals f of x minus h, the value of h is the amount of the shift. If h is greater than 0, the shift is to the right. If h is less than 0, the shift is to the left. When h of x equals f of x plus k, the value of k is the amount of the midline shift. If k is greater than 0, the midline shifts up. If k is less than 0, the midline shifts down. Example 1 says, what is the value of h in each translation? Describe each phase shift. Use a phrase such as 3 units to the left. For part A, we have g of x equals f of x minus 2, and for part B, we have y equals cosine of x plus 4. Up at the top, I put what was on the previous slide. G of x for a horizontal translation of f of x is f of x minus h, and h of x, the vertical translation of f of x, is f of x plus k. Here we are looking at just h for the horizontal translation, and notice h comes after a minus sign. For part A, we have a 2 after the minus sign, so h is 2, and this means we are going to shift 2 units to the right. For part B, we have x plus 4, which we can rewrite as x minus negative 4. Therefore, h is negative 4, and we are going to shift 4 units to the left. The work for this problem is written out on the next 2 slides. And now I would like you to try number 1, determine the value of h in each translation. Describe each phase shift using a phrase like 3 units to the left. For number 1, we have f of x equals g of x minus 3.